So, very first thing we're going to do is we're actually going to back up a little bit and pick up a couple of things that we did back before spring break. So, okay, so again, we're talking about zeros. Zeros, sometimes they call these all kinds of different things. It could be, they call these roots. It could be call them solutions. They also could call these x-intercepts. All kinds of different things they can call these. Basically, it's the answers. Whether they call it a zero, a root, a solution, an x-intercept, it just depends on how you're looking at it, what you call it. It's all the same thing. Zero, root, solution, x-intercept, it's all still the same thing. You're finding the answer to an equation of what this thing would equal. So it's still, kind of going through those parts of it. First thing before we do this, actually, we'll get some of the other stuff here in a minute. We'll do this one. The kind of new things we've got for this one. We'll back up for a minute. Let's do that first. Hopefully y'all do or don't remember this one. If you don't remember this, we'll write it back down because this will kind of pop back up again. Just want to make sure everybody's got it. But do y'all remember when we did? Yeah, I had the sticky note. Like the giant tic-tac-toe thing where we did like this, where we had like the positives up, down. We'll need that part again because that's going to tie in with everything that we're doing today. So before we get to this one, again, this is basically the end behavior we're talking about. So when we've got this giant tic-tac-toe for this part, before we talk about the zeros and the roots, everything, this is the end behavior that we need to get to first. Okay, so this is whatever expression it was we're doing in this case. Now, the difference is that before we were doing just an expression, now this is going to be an equation. But if the powers were even, so either even degree or odd degree. And again, degree was the highest power of whatever the exponent was, the leading coefficient, if you want to do that one. Okay, so we talk about the leading coefficient. It's either got an odd power or it's got an even power. So even degree or odd degree. And then from that part of it, it was either going to be positive or negative. And remember, if it was an even degree and it was positive, the left and right end were both going to be pointed up. If it was an even degree and it was negative, both were going to be pointed down. Okay, and the part that we don't really know, and again, is that in the middle it could do this a bunch. But mostly we're looking at what's happening on the ends of the graph. If it was an odd degree and it was positive, the left side was down and the right side was up. That basically we had something that looked kind of like slope. Again, in the middle, it may do all kinds of things in the middle. And that's what we're going to figure out today is what's happening in the middle of this thing. If it was negative, the left side was up and the right side was down. So you had a graph that looked like that. And again, in the middle, we didn't know what it was going to do. It was just going to do something like this in the middle. Okay, and that's what, and again, we did a little bit with this, didn't do a whole lot with this back before spring break, because that was like the first part of it. Now, second part of it, we're going to come back and use this a little bit more to kind of tie into everything. Okay, and again, that was one that if we got a sticky note, that was really kind of the same thing. That just the end behavior, if it's positive or negative, even or odd, just kind of put us in here and told us where to go with this thing. But if you had lost your notes from the first 9 weeks or didn't want to carry them over into this 9 weeks, just want to go back and show you this one because we're going to come back and use that again some more today. Okay, everybody good with that part? Everybody remember that, hopefully? Okay, again, this is just the ends. Now this is where today we're actually going to figure out what's happening in the middle. That we're going to know how much of this stuff is up and down and back and forth that we're going to do in the middle of these things. Okay, so for the new stuff. We're going to talk about the multiplicity of zeros. Okay. It's not multiply city. Anybody remember the movie Megamind? Where he was at Metro City, but he called it Metrocity? Okay. Same thing with this one. It's not multiply city. It's multiplicity. So, kind of same thing if, All right. So with multiplicity of zeros, and again, I don't know that this is something new that y'all would have done before, so let's kind of show you what's going on with this one. Basically, this is based on the power of each parentheses in factored form. So basically, you're going to take some equation we've got, and to solve everything we've done before, you have to factor stuff. So this is one of those things we're going to do just like we've done in the past. You're going to start with something, you're going to factor it, figure out what everything is, and then once you've got it factored, we're going to look at the powers you've got that's on each parentheses. That parentheses is going to tell us kind of basically what's happening with it here. So when we're talking about the multiplicity, with multiplicity, we're basically talking about the power of the zeros. So multiplicity or power is kind of the same thing for what we got going on there. Okay, so multiplicity or power. Basically, you've got two things here. If you have an odd multiplicity or odd power, then the graph at that solution again, we're talking about solution, we're talking about the x-intercept here. Crosses through the x-axis. Okay, so with multiplicity, and again, multiplicity is just the same thing. It's power, but it's the power you get when it's in a factored form. So they kind of call it a different name there. That power, when it's in factored form, what they call multiplicity, that's going to tell us a lot about what's happening with the graph on this thing. And it may not make sense, but when we put it together here in a minute, we'll kind of see what's going on with it. So. Okay. If you have even multiplicity, or again, even power, then the graph turns around. Okay, so basically, it's one of two things. Either the graph crosses through the x-axis, or it turns around. So when it's even, it turns around. And when it's odd, it crosses through. Okay, and we've already talked about maximum, minimum, so we've got everything there. Everything else is pretty much the same thing. All right, so what we're going to do, give you a couple of different problems, kind of show you what's happening with it, figure out what's going on with this thing, and see what we're going to do here. Just so you can kind of see the different parts and different pieces of what's here. So, has everybody got that written down so far? Anybody need to hold it there for a minute? Yeah. We'll hold? Okay, we'll hold for just a second. Okay, so here's what we're going to do. And again, we'll do a couple of different ones just so you can kind of see what's going on. We're going to solve and state the multiplicity of each zero. So we've got like a part A. Part B, we're going to state the end behavior. And then part C, we're going to sketch the graph. Okay, so we're going to start you off with one that's basically it's already factored, just so you can kind of see what's going on with it, and then we'll kind of change it up from there. So. Okay, so here's the problem. So you basically got two types of problems. One where it's already got it in factored form, where you've got your parentheses. The other part where it's not got the parentheses and you've actually got to go back and factor. So we're going to show you at least one of both of those. And probably show you one that's factored, because once you got it factored, that's pretty straightforward. We'll show you two where it's not factored, just so you can kind of see what's going on with it. So. Okay, so now the solving part should be pretty straightforward. It's already factored. So when you solve it, that's where you're going to take the x plus 3, set it equal to 0. You're going to take the x minus 4, set it equal to 0. So solving it should be pretty straightforward. This one we're going to subtract 3 from both sides. We've got x equals negative 3. This one you would add 4 to both sides. You got x equals 4. Okay, so there's two solutions that we have for this thing. So there's our answers, there's our solutions, there's where we've solved it. So there's the answers we're looking for. Now, for the multiplicity, though. Here's where the multiplicity kicks in, and here's how we're kind of figuring out what the multiplicity of each zero would be. Bless you. All right, so for x plus 3, we kind of went this way to get this answer. So when they ask us for the multiplicity, basically, okay, this is x plus 3 to the first power. So this one would have a multiplicity of 1. X minus 4 was squared. So for this solution, the multiplicity would be 2. All right, everybody okay with that? So multiplicity, again, is just, if you got it factored, just tell me what power you got on that thing that you factored. So x minus 3 has a multiplicity of 1. X equals 4 has a multiplicity of 2. Okay, now, what that means on the graph-wise. If we go back here, if it's an odd multiplicity, or an odd power, the graph crosses 3. So that means at x equals negative 3 has a multiplicity of 1, this thing is going to cross 3. So you can almost kind of box these together. So we got the solution at x equals negative 3 has a multiplicity of 1, which means the graph is going to cross 3. Okay, x equals 4 has a multiplicity of 2, and since 2 is an even number, that means it's going to turn around. Okay, now here's the only bad thing. I won't say it's a bad thing, but here's the part where you have to do a little bit of work for this one. To be able to do this thing with end behavior back here, we don't need this thing in parentheses. We got to have it so it's written out with one long equation, with no parentheses at all with it. So what we've got to wind up doing is, and here's kind of the shortcut for this one. Okay, this is a positive x to the first. So we've got to figure out what the degree is back here. We've got to figure out this leading coefficient. So we're trying to figure out the degree on this one. Basically, here's what you do. This is x to the first power times x to the second power. So if you can do that, that basically gives us x to the third. Both of these are positive x's, so if we multiply together, everything is positive. So basically, this thing is a positive x to the third power. Okay, which means now we can go back and kind of look at this part of it. If we've got a positive and it's x to the third power, that means the left side is down and the right side's up. So we need this part to be a down up kind of thing. Okay, so the end behavior, pull this up a little bit so you can see it there. It's a down up kind of thing. And again, we got that from basically going back and trying to, we could do the full method like we've been doing, but you don't have to worry about that part. We can just kind of shortcut a little bit just by looking at the leading terms. So basically this was x to the first, this one's x squared. So if you've got x to the first and x squared, we've got x to the third. Okay, so that's where we're getting this end behavior from, because again, we got a positive x to the third, which means that's our end behavior down here. Okay. Okay. Now, here's how we're going to graph this thing. Okay, so let's go back to what we've got. We've got solutions at negative 3 and positive 4. So we'll kind of get those parts out of the way first here. So we got one solution at negative 3, one solution at positive 4. So we need a dot at negative 3, and we need a dot at positive 4. Okay, now here's where we start tying everything together, because we haven't really done everything all together, and this is where we kind of piece it. Here's where the end behavior comes in, because we said that if we know what this end behavior is, the left side is going to go down, the right side is going up. So what we're going to do is, on the left 0, from this 0 down, everything has to go down. From the rightmost 0, everything has to go up. So that's our end behavior that we've got here. So that's what you kind of start with. So start with the left 0. Everything's got to go down from that 0. On the right 0, you've got to go up. Now, here's everything in the middle. Here's where this, and this is the first time I taught this, I didn't quite figure out all this multiplicity stuff, and I missed out on it. Here's where the multiplicity stuff comes through on this one. At negative 3, it says we're going to cross through. So once you get to -3, that means when you get to -3, you just keep on going this way. Okay, at +4, it says it turns around. So on +4, when we're coming from this direction, once we get here, we're going to turn around because we can't cross through. We're going to turn around and head back this way. And then eventually, somewhere back over here, these two things are going to meet up, and that's going to be what we're looking for. Now, exactly where these meet up, if we had a lot more time than what we have, and we don't, we would go back and like plot all these points in between to figure out exactly how high or how low this thing would go. Because it may be that we've got it drawn here, this thing would probably actually wind up being, this point that would be here would actually be at 48. But now here's the thing on this one. Don't worry about that. Because we're just want to know the basic shape of it. As long as we got the basic shape, I don't care exactly how high or how low. Because the big thing on this is that we're sketching it. We're not making an exact graph of it. We just want to have it so it kind of sort of looks like the right graph. We're not plotting every single tiny little point on this one. We just want to make sure it's got the right kind of shape and feel and turn to it. Okay, and again, if this part here doesn't exactly make sense, that's okay. By the time we do the second or third ones, by the time we do a couple more of these, it'll actually start to click and make a little bit more sense for us here. Okay, so there's our graph. And again, we use our end behavior and our multiplicity. Basically, we're putting all this stuff together to kind of make it fit and figure out what's happening. All right, everybody good with that example? Everybody got caught up there? All right, so for example 2, and again, that one was already factored, so the rest of these we're going to do, they won't be factored just because I figure factoring is going to be a little bit of a, not say a problem, but that's where we're going to need some work a little bit. All right, so for example 2, this one is not factored, which means we've got to factor this thing out. And again, if we're going to do factor and solving, the very first thing we've got to do is we've got to move everything over to one side. So first thing I'm going to do is I'm going to add this 2x to the third. So we can add it to both sides so we can get rid of it over here. That way we'll get x to the fifth plus 6x to the third equals 5x to the fourth. Okay, and then we'll move the x to the fourth over to the left-hand side too. Okay, so any of these that we have to do, if it's not set equal to 0, pretty much have to set these equal to 0. Unless it's a weird, if it had something before it was like x squared and a number, we could do that. But if it's just a normal polynomial where you've got multiple different terms in there, you pretty much get everything on one side, you set it equal to 0, and then we'll figure out from there what we're going to do. All right, now, actually, before we do any of that, we've got a couple things we can do. Now that we've got the leading term, before we do any solving and factoring, we can get the end behavior here, right? Because we got a positive x to the fifth. So leading term back over here. So the leading term is a positive x to the fifth. And so again, it's a positive and x to an odd power. So if we've got positive x to an odd, we know that the left side is going to be down and the right side is going to be up. So that's one question you can answer. That's the good thing about it being written this way, is that you can get your leading term, you know your up and your downs just by looking at it. So you got positive x to the fifth, left side's got to be down, right side's got to be up. So we know our end behavior right here. Okay, so that's the easy part. We can kind of get out of that one and figure out what's going on with it. Now, the rest of the way, here's where we got to factor. Okay, so we go to factor this thing. We've got x to the fifth, x to the fourth, and x to the third. Everybody good that we're going to take out an x to the third? So we take 3 x's out of this, we're left with x squared. Take 3 out of this one, we're left with a 5x to the first power. Take this x to the third out, we're left with a plus 6. Okay, x to the third on the outside. Not much we can do there. So that'll just kind of, we'll worry about that in a minute. This one now, we got to find the factors of positive 6. Where the sum is going to equal negative 5. Okay. So it could be 1 and 6, could be 2 and 3. Just got to make sure our signs are correct. The b term has the negative number sign here. So we know the bigger number has to be negative. But if you divide a positive 6 and a negative 6, that means this other number is also going to be negative. So they're both negative. If they're both negative, it's going to have to be 2 and 3. Okay. And that x to the third that's on the outside is just hanging out there for a minute. We're not really going to do anything with it just yet. So, so again, don't worry about that just yet. Okay, so there it is factored. Now that we've got it factored, we can go back and find the solutions. We're going to set this x to the third equal to 0. This x minus 2 equal to 0. And that x minus 3 equal to 0. Okay, so for this one, if it doesn't matter what power it is, if it's x to the third, whatever, that solution is just x equals 0. This one we would add 2 to both sides, so we get x equals 2. This one we'd add 3, you get x equals 3. Okay, so we got our 3 solutions, and then again, we need the multiplicity. This one had degree 3, so this will be multiplicity of degree 3. There was only one x minus 2, so this one has a multiplicity of 1. X minus 3, same thing. There's only one parentheses there, so it has a multiplicity of 1. Okay, but the big thing on the multiplicity is more of it's even or odd. So anything, all those are odd. So every single one of those is going to cross through the x-axis. So since all these are odd, every single one of these is going to go crossing through. If it was even, again, it would have to turn around, but anything with odd power, odd multiplicity, means it's crossing through. Okay, so we had to factor it to get it to here. Again, using those to find your solutions, but again, all the powers back here tells you what this thing is going to be, because again, technically this is x minus 2 to the first. That one's x minus 3 to the first. So x to the third had a power of 3. X minus 2, there's only 1. X minus 3, there's only 1. So then basically there we go. Okay, and that's what we're going to use to graph this thing. I've got 0, 2, and 3. So really we're going over this way. You're going to have to go with the negatives back here, but that's fine. Okay, so there's our solutions at 0, 2, and 3. Okay, now we know that they're crossing through. We just don't know which way they're crossing through. And to get the rest of it, here's where you got to have the end behavior first. We said the left was down, the right side was up. So from your very left 0, it's got to go down. And from your very right 0, it's got to go up. Because we said the left side was down, right side was up. So basically we got something like that. Okay, and then we said from there, every single one of these it crosses through, so once it goes here, it's either got to turn around or go through, so it's going through this way. This one's going through this way. And again, eventually, it's got to come back to this one. It's going to do something like that. Same thing here. Once this one goes through, it's got to eventually get back to this next zero, so it's got to do something like that. And again, that's all I'm worried about is that part. I don't care if your graph looks something more like this or like this, but eventually they've all got to do something kind of like that. Okay, so again, if it's an odd power, you're crossing through. If it's an even multiplicity, you're turning this thing around, and that's just going to depend on the different problems and different graphs you got. All right, let's do one more of these, and then we'll wrap this up for today. All right, make this one a little bit easier on us, that we don't have to move everything around. This one's already set equal to 0. Okay, terms are in descending order, which makes life a little bit easier because, again, you've got your first number here is x to the third. So, again, it's a positive number, and it's x to an odd power. So just like the other ones, that means that your left side and your right side. So again, positive, odd power, left side's down, right side's up. Okay, so that's the end behavior you get. That's the good thing about if it's not in factored form, you can just look at it and figure out what the end behavior is really pretty quick on this one. Harder part on this one is you've got to factor everything here. You've got 4 terms, so we got to group the first 2 together. And you got to group the last 2 together. And again, if there's not a plus sign in the middle, go back and put a plus sign in the middle. Okay, x to the third, x to the second, you can take out an x squared. Take 2 of the x's out, you got 1 left over. Take both of these x's out, all you've got is the 4 left over. Okay, last 2 numbers, they're both negative, so we'll take out a negative 4. So dividing by negative 4, you got an x here, do negative 16 divided by negative 4, makes that a positive 4. All right, same thing in the parentheses here and here. So now we can pull everything together. So we've got x squared minus 4 and x plus 4. Okay. And then almost one more thing here. You've got the difference of 2 perfect squares here. So this one we can take it one more step. You can make that x plus 2 and x minus 2. Okay, so probably the hardest part is going to be doing the factoring on these, because the factoring is the parts that you've really got to remember. And again, it's been a couple of weeks since we've done that with spring break in there. So that's going to be the part where you got to go back and kind of remember some things. It'll be okay that every single one of these has just the first power, because you've got x plus 2, x minus 2, and just 1x minus 4. So multiplicity-wise, they're all going to be multiplicity of 1. Solution-wise, when we said all these equal to 0, we get x equals negative 2, x equals positive 2, and x equals negative 4. Okay. Again, if they ask for multiplicity, they're all to the first power, so multiplicity would be 1 on those. But again, the big thing is with that one is that because these are all odd numbers, that means they all are going to turn around. Sorry, whoa, hang on, cross through. So odd numbers you're crossing through, even numbers you're turning around. Okay, so there's our solutions, there's our multiplicity, and there's what each one of those things is going to be. Okay, so we got negative 2, we've got a positive 2, and a negative 4. Okay, so there's our 3. And again, if we're doing solutions, that would be it. But now we're adding in the graphs on this one. So there's our 3 solutions on the graph. And again, we said back up here in the beginning that the right side's got to go up, left side's got to go down. So from the right 0, it's going to go up. Left 0, it's going to go down. Okay, and everyone crosses through. So this one's crossing through this way. This one's going to cross through that way. And again, once it goes here, it's got to eventually get back to this 0. It's going to cross through. And then somewhere, eventually, these two things are going to meet somewhere down here. But again, we're sketching, so exactly how those dips, those max and those mins look, we're not really worried about it. We're just more worried about just do we have the right basic shape of it there.